sitting at my phone, reading through the news and seeing what's going on, flipped over to LinkedIn, and there was a post from LiveWire talking about the TAMOSS launch. And rather than me doing this an injustice and talking about it, I'm actually going to pass over to David at LiveWire, who can tell us more about this. And we're really excited about this development.
Thank you. Yeah, thanks very much. So just going through, what I'm going to do now is I'm just going to show you a quick video, pause it, and just give you some commentary about what we're doing. Essentially, what we're going to do is we're going to install a local Kubernetes cluster using a process called kind. Now, I'm showing you all of this, but if you are to pull down the public repo, you should be able to get pre-file. Once you've run a couple of commands to set up the local environment, pull in the dependencies, you should be able to get pretty far with a single command, which is like task kind up. And it should be able to provision everything for you on your local machine, wire everything in and give you everything connected together, and an output of credentials at the end to start. For now, we've tweaked this slightly just because we're going to be running some curl commands on the demo. So what we're doing now is we're just building a local kind cluster. It's installing everything there. Now what we're going to do is we're going to install the platform. So the platform in this instance is all of the supporting services. So as you can see, we're deploying cert-manager, Traefik, Authentik, CNPG, and RustFS. So we lead into other open source projects. It's one of the reasons why we call this TAMOSS open source store, is because we can build this using completely open source solutions out there from the ground up. So we lean into a number of existing projects to do that. We use cert-manager for TLS certificates. We use Traefik for our ingress, Authentik for our auth, CNPG, which is Cloud Native Postgres for our Postgres systems, and RustFS for our default S3 compliance store. Now, these two, the CNPG and the RustFS, these are Authentik. These are also operators. So what we're doing is our system emits instructions for these systems, which then go and do these things. So as from a TAMOSS point of view, we're not trying to own the lifecycle management of these services. We understand these services are operationally complex. So we're not trying to run and operate all of those services ourselves. We lean in on existing open source projects to do that. So once these are deployed, we're now going to deploy the operator. So we're just deploying from our local machine. This install.yaml is what you'll find on the GitOps page. And now this has installed the operator. So now the operator is deploying, and at the end of the operator, you will essentially have a single container, a single working process inside your Kube cluster. And at the moment, that operator is running 8.00, the third release of OSS. Now what we're going to do is we're going to deploy what's known as a TAMOSS CR, a custom resource, an instance. This is us saying, we want a TAMS store. Give me a TAMS store. So we have an operator, we have all the backing services. Now I'm saying, give me a TAMS store. And we do this by deploying this basic configuration, create a namespace, which is an isolated group in Kubernetes. We then issue this TAMOSS kind. And then after this, the operator reads the instructions, reads the profile, and then goes off and starts to provision all of the underlying services. So behind the scenes, you can see we have our API, we have our database, we have our storage, we have our UI, we've also included a basic UI, and we have our worker. All these backend services remain the same and are shared, and all of these services are now specific for a single TAMS instance. So all we're going to do now is we're just going to confirm that we're running on TAMS 8.1. We can confirm that our TAMS API is running on the 8.0. Our TAMS API is running on an 8.0 container. We're just going to curl the service version. We're just going to show a default source. And we're really just kicking the tires of this just to prove that, these are endpoints that have real-world TAMS shapes. Here, we've got a demo segment on a backend. And what we're going to do now is we're actually going to register a second storage backend. Now, we can register a second storage backend with RustFS, which is what we're going to do here. But we've also tested this with registering second storage backends using external S3 compatible storage. So in our internal testing, we'll be using Backblaze. And so we're able to have an internal localized RustFS storage as well as a remote Backblaze storage. And we've been able to automate the provisioning of the cores and everything else to align that and for that to run. So we're just going to register that second storage. And the way that we do that is with another one of these custom resources. So we have a TAMOSS custom resource that sets up a TAMS instance, and we have a storage backend resource that allows to associate multiple storage backends with that instance. So using Kubernetes now, we're able to dynamically create and add backends. So here we go. Here's an example of a storage backend. Here's a basic spec. All of the secrets, we're leveraging the Kubernetes secrets backend for this. So they're all stored there separately, but our operator reads these instructions, reads all the information, and then goes off and not only provisions the RustFS bucket, but then also does the work of doing the database queries to register this within our API. So that's created. We're just waiting. It's ready. And this is us now just getting an overview of what that looks like. And we can see when we do a get storage backend within our namespace, we can see we have our default, but we have our archive, and here's our credentials stored as Kubernetes credentials there. So now we can see that we've got both are advertised on the API. Right, so what are we going to do now? We can see all these actions are happening. We're not restarting APIs. We're not having to restart anything for these things to be there. This is all happening live. We just do a basic ingest of a flow, create flow and create basically demo there, and just demonstrating that there is a that we've got it there and it's all there. Right. Just let it go through and give us some basic TAM shape. Now, one thing we're going to do is upgrading. So one of the benefits of using the operator model is it allows us to be able to control how to upgrade our TAMS instances from one version to another. So we put quite a bit of work into this. And the idea is that a TAMOSS operator will support the current major version as well as the previous major version. And the idea is that you are able to upgrade the operator. Nothing happens to your TAM stores. And then for each individual TAM store, each TAM store you want to upgrade, you can go in and say, right, I now want to patch this from being an 8.0 to an 8.1 TAM store, and the operator will handle the rest. So what we're going to do now is show how we're going to do that going from 8.0 to 8.1. So the first thing we do is we deploy the new 8.1 operator. So that's deployed, it's rolling out now. So that's rolled out, and we can see at the bottom there that we've got operator 8.1's there. Then what we're going to do is we can see that within our current TAMS implementation, we've got the TAMOSS APIs at 8.0. We're now going to patch. And now after we've patched, we're now going to be able to see that it's started to, we're waiting, and now it's upgrading our TAMS API installation. So it's now doing a rollout, Kubernetes rollout, and now it's successfully rolled out all of the various pods and containers. And we can see that our TAMS installation is now ready and running. What we'll also, and you can see that here, that we have a new API and we have a new UI and a new worker running. What this also does is it runs any sort of schema shifts. So we have the concept of doing a sort of addition and a sort of schema addition, as well as a sort of schema migration. So at the moment, we've only really been testing the schema additions and just moving that. So this supports the ability for us to add additional fields to manipulate the schema within the database as part of this patchwork. We've also included a sort of insert DB job here to do any sort of migration work or any sort of manipulation work on the database. But again, that requires further testing. So now we have our TAMS instance running at 8.1, and you can see that the schema has been migrated, and we can see, that the container itself is running as 8.1. And now we can just show that it's registering itself as 8.1, and we can see that the various elements that were there survived the various points. So that's a very quick overview of what we've built so far. It is, as was said earlier, hot off the press, which means we're looking to work with as many people as possible to test and to iron out the kinks and to make sure that we're obviously as aligned in performance as possible. I appreciate there's going to be more work for us in that area, but we feel that we've got a good foundation to do that. And hopefully we've produced something which allows TAMS to run in more areas and get more exposure and to widen the community. So again, please reach out to us. We're in the Slack channel as well as contactable on this form. And thanks very much for your time.